Let's see this question. This question is given in GATE 2014 in the subject analog circuits. In the circuit shown here, the op-amp has finite input impedance, infinite voltage gain and zero input offset voltage. Okay, those three parameters are given. The output voltage VOT is. Here there are four options given, A, B, C, D, out of which one is correct. This is the circuit diagram they given. This is the op-amp. This is VOT. Finally, we need to calculate VOT equal to how much. Here in the circuit we can observe there are two resistors R1 and R2. So from the given they have said that it has a finite input impedance. So which implies Ri not equal to infinity because they are saying that it is a finite. Second point what they said is infinite voltage gain. Voltage gain AV equal to infinity. The third point what they said is zero input offset voltage. It is Vi naught. Vi naught is equal to 0. Let us take one by one parameter and we will go through the process. Okay. First take voltage gain AV. Voltage gain AV equal to infinity. We know that voltage gain equal to V naught by VID is equal to infinity. It implies VID equal to V naught by infinity, that equal to 0. Here VID is nothing but the difference between non-inverting terminal and inverting terminal. Okay. So this we are getting VID equal to V plus minus V minus and it is equal to 0. So V plus is equal to V minus. This concept is called virtual short. Okay, virtual short. This is very important concept. Okay. Virtual short says that the voltages present at non-inverting terminal and inverting terminal are same. Okay. Then we'll move forward to this Vi naught equal to 0. They are saying that zero input offset voltage. Whenever no input is applied, no input voltage is applied, obviously output will be 0. V naught will be 0 volts. Okay, this is the meaning of zero input offset voltage. Now another point they given as Ri, which is input impedance, is not equal to infinity. It has some finite value. Okay, which means I2, I1 and I2 are the currents which are not equal to 0. So there may be some biasing currents flowing through this circuit. So I1 not equal to 0 and I2 not equal to 0. Let us go into the circuit and see this. You see here I2 is at 0 volts. So non-inverting terminal is at 0 volts. We can see inverting terminal, this point is also should be at 0 volts. Now voltage drop across R1. We will see voltage drop across R1. Voltage drop across R1. Here you can see this R1, one end of R1 is connected to ground, that is 0 volts. Other end of R1 is also connected to ground, that is 0 volts. So I1 cannot pass through this. For this I1 it has to come to this way or it has to come through this way. So this end cannot come because voltage drop across R1 is 0. So it has to pass through this way. So we can calculate V out as voltage across output is voltage drop from V out to ground. Here 0 we can consider this as ground. So V out we can write as I1 into R2. Okay, V out equal to I1 into R2. In the options, so option C, V out equal to I1 into R2 is the correct answer.